Okay, so let us start. We cannot wait for everybody to come because already it's 5 minutes past than actual time. Okay, so I'm recording. So those who are late again, see this recording. Okay, yesterday I told you about memory, right? I told you about memory, right? This memory will come in different sizes, like 1 kilobytes, 2 kilobytes, 4 kilobytes, right? 16 kilobytes. It will come in different sizes. Okay? So based on the specifications given for your microprocessor interfacing and based on the requirement, you will interface the memory with the microprocessor. That's what we are doing. Even though your microprocessor can handle 1 megabytes of memory, right? That's why this memory interfacing has come. Have you understood this? Okay. This is your memory. Okay. Now I will be going to memory chip. This is what memory chip is. A memory chip, I told you, comes in different sizes. It can be 2K, it can be 4K, it can be any size. Okay. It can be any size. And how does it actually represent it? What you need to know about the memory. See, this memory is of size 2K, right? It is actually 2048 kilobytes. Okay? If each location is byte address will be each location is 1 byte. Right? How many locations are there? How many locations? 2048 locations. There are 2048 locations. In each location, you can save 1 byte. Okay, I'm repeating this in every class because you will forget. That's the case. I'm just repeating in every class. Okay. Now, to address 2048 locations, how much address lines are required? How much address lines are required? I have told this many times. Right, to address 2048 locations, what is the number of bits required? Come on, this is very bad. I have already told you. I want the answer from you. To address 2048 locations, 2K memory, how much address lines are required? 2 to the power of 11, right? Yes or no? See, you all know that 2 to the power of 20 can address 1 mega locations. 2 to the power of 20 can address 1 mega locations. How much address lines are required to locate 2048 locations? 11. 2 to the power of 11 is 2048. 2 to the power of 20 is 1 mega. So try to understand this. It's very important for you. There is no rocket science in this. It's very easy. Simple values to remember. Right? Okay? So this 2K memory, to address 2K memory, you need 11 address lines. 11 address lines. Now can you tell me, if this memory is supposed to be 4K, how much address lines are required? 12 address lines. Right? What is the total address line you have with 8086 microprocessor? How much address lines are there in your 8086 microprocessor? 20. You have A19 to A0. Totally available address lines for 8086 microprocessor is 20. What is the available address lines for 8088 processor? 20. Also 20. Now, look at this memory device. This is the memory device, okay, of size 2K. To locate that memory location, to locate a particular memory location in this memory, you need how many address lines? 11 address lines. 11 address lines. And I have told you for 4K, you require how many address lines? 12 address lines. For 8K? 11. How much? 13 address lines. Hope all of you remember this. See, I am spending more time on this because you have to understand, you should know what exactly is that. Okay? See, this is one of the important factors of your memory. Now, what about this? Suppose if your memory chip, memory device has D0 to D7, can you tell me, is it a byte addressable or word addressable? It's a byte addressable. That means you can save one byte in one location. Exactly, we understand very well. Fine. Okay. Now, what else it has? What else it has? Read bar signal. What is the purpose of read bar signal? Whenever a low signal is given to this, that means we are reading from the memory. Are you understanding? Right. What is the purpose of write bar signal? Whenever microprocessor generates low on write bar signal, that means it would like to write the data into the memory. Have you understood this? Right? Okay. What is the purpose of this chip select bar? Tell me. Huh?
If the memory thing to the
Select. If microprocessor wants to read from this chip select signal will become low. Have you understood this now? This is very important. Don't forget this. Never forget this. Right? Fine. Okay. Now we understood the memory chip now. Okay. All different sizes memory chips. What is there as a variation in that chip are nothing but these address lines. That's all. Data line remains same. If it is byte addressable, it remains same. Right? This is your memory chip. This is what you know about memory chip. Have you understood?
yes.
Right? Okay. Now let us go forward. Let us take an example. Directly we are coming to example. First, we will see how do we interface this memory to 8088 microprocessor. Can you tell me what is the difference between 8088 and 8086 microprocessor? Only the instruction queue, size of the instruction queue and data bus. 8086 has 16-bit data bus. In one machine cycle, it can read or write how many bits from the memory? 8086 can read 16 bits. 8088 can read and write 8 bits. Right. Okay. Now, use some work to your brain. See, this memory chip has only 8 bits. Right. But your 8086 microprocessor has 16 bits. Is there any mismatches between data bus? Right? You see that even though microprocessor 8086 microprocessor wants to take 16 bit at a time, but this particular chip has got only 8 bits. Right? Nine sub. Right? It should make it equal, right? Equality. Yes. People are fighting for equality. It should be equal. Definitely, people will not keep quiet there. There is some technique which is called as even and odd addressing. Even and odd addressing. Okay? You remember Chief Minister of Delhi when you say even and odd, right? Yeah. I don't know how many of you remember, right? Okay? But this is not that even and odd, right? But this is something different even and odd. Even though you have memory chip gives you only 8 bit at a time, microprocessor will use 2 memory chip at a time, like 16 bit. That's what the fun is. For 8088, it has got 8 bit data bus. Memory also has 8 bit data bus. No mismatch at all, right? whatever 8088 microprocessor wants 8-bit data, it can take directly from one memory chip. Yes or no? But your 8086 microprocessor has 16-bit data line, but your memory chip has only 8 data line. How does 8086 get the 16-bit data from the memory? It uses at a time 2 memory chip get the data to get 16-bit data. To get 16-bit data. Have you understood this? Okay. So it's not underutilized, right? 8086 microprocessor can take 16-bit data from the memory by using 2 memory chips in one machine cycle. One lower byte it will take from given address, higher byte it will take from the odd address, given and odd address. We'll see that. It's very interesting one. Just try to follow me. Okay? Come to every class. If you're not understood, ask questions. Okay?
So
Now,
then 8088 come after 8086.
no, 8088 came first. After the 8086 came. The numbering, this don't go by numbering. It is not in the proper serial order. Right? Okay? Fine. There are certain applications that want 8-bit. That's why they come out with the 8-bit microprocessor. Right? Difference between 8088 and 8086, just in terms of 8-bit. Right? See, there are many applications which requires only 8-bit data. Yes or no? In such applications, okay, why need to go for 16-bit microprocessor? This cost is involved in this, right? Cost to manufacture, cost of a 8088 microprocessor is less than cost of 8086 microprocessor. Why? Tell me.
You don't need the extra.
See, 16-bit means you need more number of silicon, right? More number of transistors, right? More number of flip-flops. 16-bit means 16 flip-flops are required. Suppose if I say only 8-bit, you need only 8-bit. Whatever is your ALU, your registers, everything is 8-bit only. You're going to have a savings, right? So cost of the 8088 chip is less than cost of 8086 chip. I've understood this. For some applications, people will not go for the higher version, right? If I'm okay with my 8-bit, my entire application is running well with 8-bit, why I should go and buy 8086 microprocessor? I can simply buy 8088 and get my work done, right? I have the savings over there. I've understood this. Okay, that's where this 8088 and 8086 microprocessor comes to picture. Okay, now what we'll do, see the question. Using 2K byte memory chips, interface 8K bytes of memory to 8088 microprocessor. What is the total amount of memory to be interfaced? Total memory to be interfaced is 8K. But what is available? 8K memory chip is not available. Assume that 8K memory chip is not available. Only 2K is available. So how many memory chips are required for interfacing to interface 8K of memory here? You need 4. That is the first thing should come into our mind moment you see the question. Now, what is the address range? Address range is not given in this, right? If address range is not given, you can assume any address, starting address. You can assume any starting address. Okay, what is the ending address? You know that. I've understood this. Okay, you can assume any starting address and get the ending address. I have already told you how to calculate the ending address. Right? Anybody doesn't know, please update. Right? Okay. So you know now that you need 4 number of memory chips. Okay. And what is the address space? What is the address space? Address space, since it is not given, you know how to calculate the address space, right? So what is required? The main requirement to interface 8 kilobytes of memory to 8088, first you need to know what is number of memory chips. What is the address space? Right? Here number of memory chips is going to be 4. You need 4 2 kilobytes memory chips. Understand this. Next, address space. If the starting address is not given, you are actually free to choose, free to assume. Suppose if I assume my starting address to be 0000H, what is the ending address?
0,
For 8K memory?
0, 1,
0, 1. Are you sure? Come on. 8 KB. 8 KB is how much? 2 to the power of how much? 2 to the power of 13, right? Okay, correct. All of you know how to do this. Okay. Now, this is the address range for what? Tell me.
8 KB.
8 KB. But 8 KB, whether 8 KB memory is available?
Oh.
No. Okay. So you are dividing this 8 KB into how many memories?
Oh.
4 memory chips. Okay. Each one is 2 KB. Can you tell me the address map of this? Memory map. It is called as memory map. Memory map. Okay. Okay. Anyway, this is starting from 0000 00. Okay. Can you write? Can you write all the things?
Can you tell me what is that phone number of memory chips you know?
Why? You have one tarbuja.
Yes.
There are 4 people. कितने piece करोगे?
4.
बस 8. You have only one. You are required to interface 8 kilobytes of memory. But shopkeeper say I have only 2 kilobytes. Are you going to come back? No, right? So you can use 4 2 kilobytes memory to make it as
8.
understood.
Yes.
Okay, you complete this. Come on, this is what to do. Right. Complete this. I have already told you. Write the address map. Don't sit. You sit today, tomorrow you will have to stand and run. Right? Complete this. What is the address range of this? What is the address range of this? What is the address range of this? Fine. Okay? So, in front of your name, you sign and pass it back. Okay? Don't sign for others. Okay? Fine. What is the address range? You got it, right? Everybody got it? Address range of this is 000H to 07FF, right? That is for 2 KB. Next address range plus 1 from here. It is 008002. Add 7FF to this. How much? Add 7FF to this. It is 00 F. What is the address range of this next?
0, 1.
01000. What is the ending address of this? This 2 KB? 017 FF. What is the address range of this last one? Come on, plus 1.
0, 1,
018 F. H. What is the ending address? 01.
Just starting 0, 0, yeah. 0, 1, 8, 0, 1, 8, 0, 0.
018?
0, 0.
Sorry, 00. Yes. This is very important. If you know this, 30% of the memory interfacing is done. First, you should know how to divide that memory. This is for 8 to the 88, okay? This is for 8 to the 88. After that, address mapping. Also, it is called as address space. What you written is address space. What is the address space of the total 8 kilobyte memory? This one. Since 8 kilobyte memory chip is not available, you are using 4 2 KB memories. So each memory will have its own address space in the range 0000H to 01FFFH. Have you understood this? Right? Next is going to be decoding logic. You have to get a decoding logic. Right? See, microprocessor, yesterday I told you, 4 hours I took to make you understand. Right? Now, microprocessor is interfaced with 4 memory, right? 4 memory. Now, depending on the address generated between this range, it has to select any one out of 4, yes or no? Right? How does the microprocessor does it? By using decoder logic. Decoder logic. Try to understand this. Okay? Fine? Okay. Let us now design decoder logic. Before that, I will tell you whatever I have told you just now. 8K memory, 4 2K memory chips required. Memory mapping, we have already done it. RAM 1 is from 0000H to 07FF. RAM 2 is from 08000 to 0FFF. RAM 3 is from 01000H to 017FF. RAM 4 is. So, if it consider total 8 KB memory, it is 0000 to 01. So, whenever microprocessor generates any address in this range, only this chip has to be selected. Other chips should not be selected. Whenever microprocessor generates any address in this range, only memory chip to be selected is RAM 3. Other things should not be selected. That is where we use the decoder which I told you in my yesterday's class. Yesterday I said 3 to 8 decoder can select how many lines? 8 lines. Just by giving 3-bit input, which is coming from the address lines. Right? So out of A19 to A0 address line, we can use any 3 address line which is unique to this RAM 1 as a input to the decoder logic.
So here we don't need 3.
Right? You can use, of course, you can use,
4 memory.
of course, no problem, because only 4 memory, you can use 2 to 4 decoder. Right? Suppose 2 to 4 decoder is not available, what you will do? Will you keep quiet?
Oh.
Huh? Will not keep quiet, right? Use 3 to 8 decoder. Maybe four lines you are wasting, doesn't matter. Right? If it's asked in the question that you use only 3 to 8 decoder, use only 3 to 8 decoder. Understood this, okay? So, this is very important step. Everyone should understand this. Okay, now see here. This is where we are going to interface a memory. See here. This is a memory chip. This is the memory chip. Okay? And what you can see here, that memory will receive signal from memory write, memory read from the microprocessor, and there's the data bus, right? And how many address lines are required? How many address lines you are going to use from the memory itself? 12 address lines. 2 kilobytes, right? 11 address lines. So there are 3 chips like this. 3 more chips like this, okay? And you can see that how we are going to decide, how we are going to design a decoder logic for this. Listen carefully, it's very important. See here, your microprocessor has address lines A19 to A0, right? Yes or no? Right? How many address lines are there? How many address lines are there for my microprocessor, 8088 microprocessor? You have A19, A18, A17, A16, A15, A14, dash, 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 A0. Okay, now for address decoding logic, we are going to use only address lines of the microprocessor. Right? Okay. So out of A19 to A0, your A10 to A0 is required to select the memory. Yes or no?
Right.
So this much address lines out of the microprocessor's main address line will go directly into the address lines of the memory chip. See, this is address line of the memory chip. Remember this. Okay? This is address line of the microprocessor. Now we are going to use the address lines of the microprocessor to interface this memory. Right? Now A0 to A10 of the address line, okay, A0 to 10, this address line will be directly connected to the address line of the memory. Now, remaining address lines, this one, A14 to A19, is given to the input of the address decoding logic. The remaining line, because you have to make use of entire address, right? What's the purpose of address generated by the microprocessor? To locate a memory. To locate a memory, right? Now, to locate the memory, which we are going to design now, okay? We are using A0 to A10 directly as the address line of the memory chip itself. Okay. Now, what about remaining A14 to A19? This also have to make use of, right? And this is used as an input to the address decoding logic. Now, what is our duty? What our duty is to design this address decoder logic. Our duty is to use a decoder here, okay, and use this address bits, address lines A14 to A19 and get a decoder. Okay, now let us see how can I use the remaining A14 to A19 as an input to the decoder logic and do proper decoding. Do proper decoding. Listen carefully. First, what you have to do is
So why are we considering from A14 to A19?
that is what I am going to teach you now. Here I said I am going to use this as an input to the decoder logic. Right? Now, how I am going to use, I am going to tell you in the next slide now. Right? Sorry, I am very sorry. Exactly. It is from A11 to A19. I am sorry, just right. I have not written that, okay? But it is A11 to A19 because remaining address lines are A11 to A19. Exactly. Right? Because A0 to A10 goes directly to the memory. But remaining address lines, I am going to give it as an input to the decoder. Have you understood now? Clear? Fine. Okay. Let us see how can I make use of that. Okay. Hope all of you remember this, right? Once upon a time, long ago, right? In the lab, in the theory, a poor guy, professor like me, taught you, right? That this is a decoder logic, right? And must have stressed, told that this is going to come back once again to meet your brain in microprocessors. Yes or no? Right? Rushil remembers it. Right? Okay. This is a decoder. That's what I told you. Same decoder which I said yesterday. Same decoder which I said yesterday. Right? It has got three inputs. ABC, which is called as select input. And it has got how many outputs? This is active low or active high? Active. Come on, my dear. Anandan. Now, sorry, okay. But in the examination, no use of telling sorry. Right? You lose marks. Be careful about this. This is active low. Right? Active low means what? Whenever you get 0, 0, 0, this line will become 0. All other lines will become high. Right? Similarly, whenever you give 1, 1, 1, this line will go 0. All other line will be. Have you understood this? That's all. Fine? Okay. Now, let us come to this table. Right? What is this table? Tell me. This is the truth table for this. That's what I told you here. Right? Okay. Now, see these people. Who are these people? Unnecessary. Extra 3 lines. Who are these three people? These 3 people are nothing but the enablers. This chip will be selected. Can you tell me when this chip will be selected? Tell me.
1, 0, 0.
Whenever you have 1 here, 0 here, 0 here. Yes or no? Whenever you have 1 here, 0 here, 0 here, then only whatever I said is going to happen. See the truth table here. See, whenever you are having 1 here, 1 here, 0 here and 0 here, right? And when you give ABC 0, 0, 0, see your O0 is going low, all other are high, right? See, for all the cases, can you see here? For all these cases, your G1 is 1, G2A is 0, G2B is 0. Then only you can see a decoding action, yes or no? Then only, can you see this particular part? Then only the decoding action is happening in this. When these are something else other than this combination, can you tell me what is output? Irrespective of whatever input you give, all output is going to be always high. Have you understood this? Right? Put your name only, right? In the attendance, I'm going to call your names. If I find any extra names, it's not going to get attendance. Don't worry. Okay? No use of putting others in that. Okay? If at all you think that you can do it, but don't do it. I just want to see how much sincere you are. Right? Okay? It's very important. Right? Okay. So have you understood this decoder? This is called as 74LS138 decoder. This was already done in your previous semester in digital design. I don't know how many of you remember that. Right? You don't remember something done yesterday. You may feel that this fellow is asking something done last semester. Right? Okay? Understood this. Okay? Fine. Now let's see. We are going to use this decoder in the decoder logic. Right? So what's the input we are going to give? See, you have already said, we already seen that for a decoding logic, okay, remaining address lines are given, right? All remaining address line. That means, what are the remaining address line in this problem we have seen? A11 to A19. So entire A11 to A19 address lines are distributed among A, B, C, G1, G2A, G2B. How we are going to do that? For that, we need to identify what should be given to ABC and what should be given to other pins. That will come from this table. See here. What is this table? Tell me. I want you to tell me this. What is this?
First time.
That's correct. What is the 0101?
Starting address.
Exactly. It is the starting and indicators of the RAM 1. It is written in terms of entire. Why I have not written the last A16 to A19 in this?
For the starting.
Why I have not written this? It's confused, my dear.
It will always be same.
It's always same, na? Right? It's always same. You can put it, no problem. Actually, address lines are from A0 to A19 because you see the address map. Your A19 to your A19, A18, A17, A16, you always 0, right? Yes or no? That's why I have not represented this. Fine? Okay? Now, see this table. What is this table? First you write this table. In the design process, first you write this table. See, this is the starting address of RAM 1, that is 0000. This is the ending address of RAM 1. Do I need to explain how this 0001 came? Right? We are writing only this much. 0 means all 00000. See, and this is 0000. 7 means 0111. F means 111. Like that you have to write. Have you understood? Right? Is there anything extra reading is required for you to remember this? How to write this table? Yes or no? Anyone not understood how to write this table? It's very easy. Right? A small kid in our first standard can write this. Yes or no? Yes or no? She tell us. You accept it, right? Fine. Okay. Can you write the table for the next one? RAM 2. Come on. Come on. RAM to table. You should write, my dear. Huh? This is for RAM 2, yes or no? Right? And this is for RAM 3. And this is for RAM 4. Yes or no? This is for RAM 1, RAM 2, RAM 3, RAM 4. Right? Understood this? Now, which are the lines will go directly to the memory? A0 to A10, right? That means your A0 to A10, see here, it is always 0, 0, 0 to 1, 1, 1, 1. Right? That's what you require, right? See, you are going to select how many locations? How many locations? 2K locations, right? 2K location is from 0, 0. See, count how much? This much. This much. Right? If we take it in a hexadecimal, see this is 0, 0, 0 to 1, 1, 1. These such combinations you have, right? Right? So your last location is 1, 1, 1, 1, 1, 1. You write it in the hexadecimal. Suppose if you write this hexadecimal, what will be the value for this? For 2K locations, it is starting from 0, 0, 0, 0 to 1, 1, 1, 1, 1. What is the hexadecimal value? Just take hexadecimal value like this. 1, 1, 1, 1, 1, 1, 1, 1, 1, FFF. Yes or no? It is from 0, 0, 0 to 0, 0, 7FF. 7FF. 0, 0, 0 to 7FF. Yes or no? That much location. Here also once again, it is 0, 0, 0, 0 to 7FFF. 0, 0, 0, 0 to 7FFF. So this A0 to A10 will select the location among 2K bytes. So this will go directly to the address lines of the memory chip. Now, which are the remaining one? Your A11 to A19. A11 to A19 will go to the input of the decoder logic. Now, tell me, just look at the bits from A11 to A19. Can you tell me which are that 3 address lines unique to this RAM 1, RAM 2 and RAM 3? Unique. Yes. Common means unique to the particular RAM 1.
Yes, sir.
A11, A12? Yes, very good. You are catching. Good, good, good. See, can I give this as the input ABC? Yes. I can give this input as a ABC, right?
Yes.
Right. Yes or no? So I can give this input as a ABC to the decoder logic, so that a particular output line will be active low and that is connected to chip select of the memory. Right? Fine. Can you continue this from the next class? Can you give me your? I'll just quickly call your name. Those who are right here. Mohammed Sinan.
Yes, sir.
Okay. Sopana.
Yes, sir.
Hitesh.
Yes, sir.
Mohammed Zubair. Mohammed Zubair, what is this man? 1 second, you want to say? Give me man. What's the problem? Mohammed Zubair is not this. Who wrote this? Arisa.
Yes, sir.
Mustafa.
Yes, sir.
Sania. Harshit.
Yes, sir.
Prathamesh.
Yes, sir.
Suleiman.
Yes, sir.
Prakriti. Dipti.
Yes, sir.
Shashi. Nupur.
Yes, sir.
Mahindra. Patel. Dhairya. Varnika. Naganandan. Nikita.
Yes, sir.
Risa Murthy.
Present, sir.
Kailash.
Yes, sir.
Venkat.
Sir.
Lin.
Yes, sir.
Rishikesh. Rishikesh Dade. Sharmi Suraj. Malvika. Sarashkan. Sania. Siksani. Naina Siksani. Sneha. Gaushik. Mubashir. Mubashir absent. See, this is what the problem is. Huh? Don't do this. Syed Bihar.
Yes, sir.
Rashida. Janvi. Shifa. Okay. See, go extract in the second. You want
I know which computer it is not.
We'll continue from here. Okay.